Alright, Algebra 2, here's your second practice problem. It says Rosalie looks at cable locks. Each position can be set from 0 to 9. How many different codes are possible for each lock if no digits are repeated in each code? Okay, so we have a 3-digit cable lock, a 4-digit cable lock, and a 6-digit cable lock. Alright, so let's look at the first one, a 3-digit cable lock. Well, first of all, we have to decide if this is going to be a combination or a permutation. It's going to be a permutation because if it's a code, it's going to make a difference what order the numbers come in. So we know it's going to be P. Alright, so now we got to figure out how many we're choosing from. It says it can be set from 0 to 9. A lot of people think, okay, so there's 9 possibilities. But 0 through 9 actually is 10 numbers because it's 1, 2, 3, 4, 5, 6, 7, 8, and 9, but also 0. That's what a lot of people forget. So there's 10 total options. So we're 10, and we're choosing through permutations 3. For this one, we're going to be 10, P4. And for the last one, for a 6-digit cable, it's going to be 10, P6. So let's calculate each one of those out. Remember that you got to be able to use the formula. Alright, so we have, for 10P3, we have 10 factorial divided by the difference of these, which is 7 factorial. So you can show 10 times 9 times 8 times 7 times 6 times 5 times 4 times ... to 1 over 7 times 6 times 5 times 4 times all the way to 1. Now, some of you guys already knew that everything from 7 below is going to be canceled, but I'm showing this for those of you who don't. So there's the 7s get canceled because times 7 and divided by 7 will cancel each other. Same thing with 6, 5, 4, and everything all the way to 1. So with 10 times 9 times 8, which is 720. Alright, I'm not going to go through the same formula with all the rest of them, but what you should get, I'm going to write up the answers up here. We should get 720 for this one. We should get, this one will give us 5,040. And then last but not least, 151,200 possibilities. That is a lot of possibilities. So you notice how exponentially larger it becomes just by adding a few more digits.